Here's a question that has to do with confidence intervals. This one's a little bit misleading because actually what they're doing in this question is they're giving you the confidence interval already. These two values right here are the lower and the upper limits for the confidence interval. 63% is the lower limit and 69% is the upper limit. They're giving you those values already and they're asking you to find the point estimate and the margin of error for the confidence interval. So remember what a confidence interval really looks like is it's just an interval on the number line. We have our lower limit and our upper limit. Our interval is going between those two. The point estimate, if we're talking about proportions or means, is exactly in the middle, halfway in between those two limits. This is our point estimate right here. So the first thing we could do is figure out exactly what number that is. It's just going to be the average of the lower limit and the upper limit. We could take these two and add them together and then divide by 2, and that would give us our point estimate. When we do that, that's going to give us 66. So 66% is our point estimate. Then for the margin of error, it's just the distance between the point estimate and either of the two limits for the confidence interval. All we would have to do to find our margin of error would be to figure out how far it is from 66% up to 69%, or from 63% up to 66%. Either way, it's going to be 3%. Technically what we did there was we took one of the limits and subtracted with the point estimate. We could have done 69% minus 66%, and that gives us 3%. Now we're going to work on finding some confidence intervals. We're going to do these with StatCrunch. The first thing you need to know when you're doing a confidence interval is which parameter are you talking about. In this one, if you read all the way through here, what it's asking is for the confidence interval for the true population proportion. That's the key word right there, is proportion. So we're trying to estimate the proportion of union members that favor the Republican candidate for governor. That means when we do this in StatCrunch, we're going to use proportion stats. That's why this is so important, because if we're using formulas, this will tell us which set of formulas to use. If we're using StatCrunch, it tells us where to go in StatCrunch. If I'm in StatCrunch, I want to go to Stat, Proportion Stat. If I'm in StatCrunch, I want to go to Stat, Proportion Stats, One Sample, and in this one I don't have a data set, so I'm going to have to do with Summary. This is going to ask me for the number of successes and the number of observations. What that means, for the number of successes, that's going to be a frequency or a number out of my sample. Up here where they said that 297 out of the 400 favor the Republican candidate, this is my number of successes. So this is always going to be just a number, not a percentage. And then the number of observations, what they mean by that in StatCrunch is the sample size. In this case, it's 400. I can put those two things in to StatCrunch. I'm doing a confidence interval, and I want this to be a 90% confidence level. I'm going down to the bottom and clicking on Compute. This gives me my lower limit and my upper limit for my confidence interval. If I'm writing it in an interval form, I'm just going to put the lower limit first and then the upper limit. This also gives me something else. It gives me my sample proportion. That's really just the 297 divided by the 400. But it calculated it out for me. If I know my confidence interval limits in my sample proportion, I can also write my confidence interval in a different format. Sometimes they ask for it in a format like this. This is the sample proportion, and this is the margin of error. I know the sample proportion, and I can find the margin of error from the numbers that I have. My sample proportion is exactly in the middle of my confidence interval. My margin of error is how far it is from my sample proportion to either one of these two limits. For example, I could take my upper limit and subtract my sample proportion, and that would give me my margin of error. If I take my upper limit and subtract my sample proportion, that's going to give me my margin of error, which is going to be 0.036. So then, if I'm writing my confidence interval in this format, it would be 0.7425 plus or minus 0.036. In this question, we're trying to plan a new poll to determine the percentage of union members in New York that favor the Republican candidate for governor. Since we're talking about a percentage, that means that we're looking at a proportion problem. In StatCrunch, we would be using the proportion stats. But in this case, we haven't done the poll yet. We're trying to find the minimum sample size that we have to use in order to get a margin of error of 3 percentage points and a confidence level of 90%. That means this is a minimum sample size problem, and we do know that it has to do with a proportion. There were two formulas for this, depending on whether you have a prior estimate or whether you don't. In this one, we do have a prior estimate because it says we're going to use the previous survey. And in that previous survey, our sample proportion was 297 over 400, or as a decimal, that's 0.7425. We're going to use this as our prior estimate. Since we have that, then the formula that we're going to use looks like this. And here where we have the P star, that's the prior estimate. We have our prior estimate already, so we're going to put that number into these two places. We need to find our critical value, and we need to know what the E is to put in here. The E part is easy because they give that to us in the problem. They say the margin of error has to be 3 percentage points. 3%, we're going to have to change to a decimal, so we're going to make that 0.03. The next thing I need to know for the formula is my critical value. Since this is for a proportion, that means I'm going to use a critical value from the standard normal distribution, and my confidence level is 90%. So this is one of those three that you really should have written down before you go to take your test, because these ones are used very frequently. So for that one, this should be one that you had written down. It would be 1.645. Now I have all three of the numbers that I need to go into this. So for my formula, I would have 1.645 squared times my P star, which is 0.7425, and then 1 minus P star. And on the bottom, I have to make sure and use the decimal value for my margin of error. That's 0.03, and square that. When I put that in my calculator, I got 574.86. For the minimum sample size problems, you always have to round up to the next whole number, no matter what. So this one, I'm going to round up to 575. For the next question, we have the same thing, only this time we don't have a prior estimate for the sample proportion. That just means we're going to use a different formula. We're still trying to find the minimum sample size. This time our formula has our critical value squared, and then instead of the P star and the 1 minus P star, here we just have 0.25, and on the bottom we still have E squared. From where we did this in the last one, we already have these two values. This one comes from the fact that our confidence level is 90%, so that value is 1.645. And the E we get from the fact that we wanted to have a margin of error of 3 percentage points. That makes this 0.03. We always have to change that to a decimal. Putting this in my calculator, I get 751.67. Again, I have to round that up to 752. That's my minimum sample size.